The tower was built to stand against bombers, hurricanes, and the worst the Atlantic could throw at it. But one January night in 1961, Texas Tower 4 collapsed without warning, taking all 28 men on board with it. From the beginning, sailors had nicknamed it Old Shaky. Some believed the structure was doomed from the moment it left dry dock. Others whispered about Soviet trawlers prowling nearby and whether Cold War secrets kept crews aboard long after safety had slipped away. Families were left with no answers, only rumors, speculation, and grief. Was the tower destroyed by the storm, by fatal engineering flaws, or by something far more secret? On the 1st of August 1952, researchers at MIT's Lincoln Laboratory issued a report about how to detect Soviet long-range bombers before they reach American airspace. At the time, the US relied on a mix of land-based radar, radar-equipped aircraft, and Navy picket ships stationed in the Atlantic. All had limitations. Aircraft could only remain airborne for a few hours at a time. Ships could cover long distances but were vulnerable to weather and mechanical breakdowns. The Lincoln Lab proposed a bold alternative: fixed radar stations placed offshore on shallow shoals about 80 to 100 miles off the US coastline. The Texas towers looked like oil platforms in the Gulf of Mexico, already a familiar sight by the early 1950s. These radar platforms were permanently anchored to the seabed and could stay on station for years to provide stable, long-range radar cover. This wasn't just a technical experiment, it was directly tied to nuclear strategy. In the early 1950s, Soviet bomber aircraft like the Tupolev Tu-95 Bear had the range to cross the Arctic and attack American cities. Detecting them in time to launch and intercept was critical, and every minute would count. After Pearl Harbor in 1941, long-range detection was a high priority. The Air Defense Command was constructing the distant early warning line across Alaska, Canada, and Greenland to detect Arctic threats, but the Atlantic approaches were exposed. High-altitude bombers could be tracked, but low-flying aircraft below 500 feet would only appear on radar quite close to their targets. The Texas towers were meant to close that gap. The tower's radars were built to plug directly into the SAGE network, an advanced system of large computers that aggregated data from many sites to automate and speed up air defense tracking and interception, replacing slower voice relays to ground controllers. The ambitious Cold War plan proposed 5 radar towers anchored on North Atlantic shoals to push US radar coverage hundreds of miles seaward, adding up to 30 minutes warning against Soviet bombers. The Navy would oversee the design and construction, and the Air Force would operate them. A consortium of consultants and engineers was put together along with Woods Hole Oceanographic Institute, who would supply critical wind and wave data for the harsh site conditions. By October 1st, 1954, the engineering study confirmed that the towers were technically feasible, and so the Texas Tower program moved from conception to construction. 2 architect engineering firms were appointed to design the towers. Both had marine engineering experience, but not at the scale of this project. The design brief was simple in theory, but complex in practice. Build a fixed radar station in the Atlantic, strong enough to withstand hurricane-force winds and heavy seas, but light enough to be built in sections and towed into place. Winter storms in the Atlantic can easily produce 10-meter waves. Hurricanes in the summer and autumn can push winds up to around 120 miles per hour, and waves over 15 meters aren't unusual in deep water. A triangular steel platform was designed with 55-meter sides to stand on 3 hollow steel caissons almost 4 meters in diameter, filled with concrete lining and reinforced with steel. Each leg housed fuel tanks, water storage, and service tubes. One leg had a seawater intake and desalination plant to make drinking water. Each tower would weigh over 6,000 tons and rise almost 105 meters from seabed to the radar domes. about the height of a 30-story building. The platform deck would sit 20 meters above the waterline, high enough to clear most waves, but still exposed to the largest swell. 3 legs would give stability, distribute the load evenly, and minimize construction compared to a 4-legged platform. But the triangular layout also meant that if one side was weakened, the stresses could quickly transfer and amplify across the structure. Construction was planned in 2 stages. Triangular platform decks would be built in dry dock with radar towers, living quarters, and equipment already fitted. The legs would be fabricated as long hollow tubes with internal bracing. Towers 2 and 3's legs were integrated into the platform in dry dock, so the entire assembly could be towed to sea. Then the legs could be lowered and driven into the seabed to secure the structure. Tower 4 would be located in much deeper water, about 56 meters compared with 17 meters for Tower 2 and 26 meters for Tower 3. Towers 2 and 3 could be installed in a simpler, sturdier way. The Navy decided Tower 4 would need to be assembled at sea. The Texas Tower program moved into construction in the mid-1950s. Each of the 3 towers followed a slightly different path to completion, and the problems for Tower 4 stood out from the beginning. Construction of Texas Tower 2 began at the Bethlehem Steel Shipyard in Quincy, Massachusetts, in the dry dock with its 3 legs attached to the triangular platform. After fabrication, the entire structure was floated out as a single unit and towed to its site more than 86 nautical miles off Cape Cod. The legs were lowered into about 17 meters of water, and the structure was driven roughly 19 meters into the seabed. Because the legs were buried deeper than the water was high, the tower had a solid, stable footing. Tower 2 became operational in 1955 at a cost of $12.3 million. It was the proof of concept, a functioning offshore radar platform permanently fixed to the seabed with living quarters and radar equipment. Tower 3 sat about 57 nautical miles southeast of Nantucket in roughly 26 meters of water. Its legs were longer at 61 meters, but the build method was the same. Construct the legs and platform together in dry dock, float the whole unit out, and set it in place. It was finished in May 1957 for just over $10 million. Its legs were driven about 18 meters into the seabed to give it a firm foundation like Tower 2. Texas Tower 4 was more complicated. It sat about 55 nautical miles south of Long Island and 74 nautical miles east of New Jersey, in water almost 55 meters deep, more than twice the depth of the other 2 platforms. That depth meant much longer legs, about 77 meters in total. To handle the extra stress, engineers added 3 tiers of steel cross-bracing, staggered along the submerged length of the legs. The installation was completely different. Instead of towing the platform and legs as one piece, Tower 4's legs, the template, were floated out horizontally and then upended into a tripod at sea. The platform was floated between them, gates closed to grip the legs, and the whole structure was jacked up into position. From the start, Tower 4 showed worrying signs of weakness. During the tow to its site in 1957, rough seas bent and even snapped some of the diagonal braces. Instead of hauling the structure back to dry dock, the crew tried to patch it at sea. When the legs were finally raised and fitted to the platform, they scraped against the steel and left deep dents, about 25 centimeters deep and nearly 2 meters wide, right where the A and B legs faced the shore. The damage was visible, and so was another problem. The legs were set only about 5.5 meters into the seabed. By comparison, Tower 2 and 3 were driven more than 18 meters into the sand. The difference meant Tower 4's foundation was far shallower and far less stable. On paper, it looked like a formidable fortress. In reality, it carried hidden weaknesses from the very moment it was built. By late 1957, the Texas Towers weren't just prototypes anymore. Crews were aboard, the systems were running, and radar data was flowing back to the mainland. The idea of offshore radar platforms had come to life, but the real thing proved less steady and dependable than the plans promised. Each tower ran like a tiny, isolated sea base. It had living space for 75 enlisted men and 8 officers, with a galley, mess hall, sick bay, and spots to unwind. The lowest deck held tanks, pumps, and maintenance gear, while the upper decks carried the radar and communication station. Crews rotated over long shifts, often staying for weeks. Supplies and relief crew arrived by ship or helicopter. Early on, the converted Coast Guard cutter New Bedford did the runs, lifting people aboard with a crane and a donut-shaped personnel basket that felt smooth in calm seas and like an amusement park ride when it got rough. Later, helicopters like the H-21 Workhorse and the Sikorsky S-61 took over, moving up to 28 men at a time. Despite the harsh, noisy, rattling environment of the North Atlantic, the sailors formed routines. Baking fresh bread, stretching limited ingredients into meals, and finding small rituals to keep morale up in their floating outpost. The towers were built to push radar coverage deep into the Atlantic, and they did that reasonably well. The radars could spot large aircraft like the B-47 at high altitude, about 200 nautical miles out. But at low altitudes, the system struggled. Aircraft flying around 150 meters above the waterline were only visible 50 nautical miles out. That left a serious blind spot for low-level bomber attacks, the very thing the towers were meant to stop. Airborne early warning aircraft still had to patrol and fill in what the towers couldn't see. Even when the radars worked, getting their data back to shore was another challenge. The towers were designed to feed information directly into the SAGE computer system, but the upgrade lagged behind schedule. In the meantime, operators had to relay much of it the old-fashioned way by voice over radio. Summer weather added to the trouble. Sudden temperature shifts bent radar signals, cluttering screens with false echoes and ghost aircraft. Space on the triangular deck was crowded. 3 radar domes, multiple communication dishes, and heavy antennas all competed for room. Below them, operators worked in cramped radar rooms that were hot, noisy, and constantly vibrating from the diesel generators, spinning antennas, and the restless motion of the sea. With so much equipment jammed so close together, electromagnetic interference was inevitable, and the result was a system that was often unreliable just when it was needed most. One of the biggest problems was motion, which engineers planned for but could never fully remove. The towers were fixed, but some storms made them sway and vibrate. The shaking happened so often that Air Force crews nicknamed Tower 4 Old Shaky. This wasn't just uncomfortable for the crew, the radars needed a steady platform to work properly. For Tower 4, the issue was worse. The deeper water meant its long legs would flex even more. Its shallow foundation meant a weaker grip on the seabed. Damage during construction left weak points that amplified the vibration. By late 1958, barely a year after completion, Tower 4 was already showing more structural stress than expected. By 1958, the Texas towers were built and working, but their toughest test was still ahead. The North Atlantic is harsh, and within a year, storms would hit Tower 4 and reveal how fragile its design and construction really were. On the 24th of August 1958, NOAA spotted a tropical storm about 260 nautical miles east-northeast of Miami. Within days, it strengthened into Hurricane Daisy with winds up to 120 knots, which is about 140 miles per hour. Daisy passed almost directly over Tower 4. The storm brought waves over 15 meters high and winds stronger than the tower was built to handle. After Daisy moved on, divers inspected the tower. 15-meter seas can toss a steel freighter like a toy. A tower doesn't ride the waves, it takes the full force head-on. Every surge drives stress into the legs. Time after time, that's the pattern I keep uncovering on Waterline stories. The ocean pushes every structure, every design, and every person right to the edge. The divers found loose bracing at the 20-meter level on the AB side, the same side damaged during construction. The bracing wasn't holding firm. The Navy called back the original contractor to make repairs. Before the work could finish, Tower 4 took 5 more storms in the winter of 1958-59, with winds up to 90 miles per hour and waves of 10 meters. Repairs weren't completed until May 1959. Afterwards, divers reported the tower's motion had clearly decreased. For the moment, it seemed stable. That stability didn't last. In January 1960, crews on Tower 4 reported strange noises and what they called abnormal motion beyond the usual shaking they were used to. Another dive inspection was ordered. By February, divers confirmed more loose bracing in the AB plane at both 8 meters and 23 meters, showing the same weaknesses had returned despite earlier repairs. The Air Force brought back one of the original design firms to assess the structure. Their verdict was clear. Without immediate reinforcement, Tower 4 might not last the year. The chief engineer warned, "This is an emergency. If we do not do something about this tower, we may lose it unless something is done by August 1st. Engineers proposed adding X-shaped steel cross braces just above the waterline to stiffen the legs. It was a big job, priced at over $500,000, which was almost 5% of the original construction budget. The work finished in August 1960, and the design engineers certified that Tower 4 was back to its original strength. They said it could again handle winds up to 125 miles per hour and breaking waves of 11 meters. But barely a month later, another storm would test those claims. In early September 1960, Hurricane Donna crossed the Atlantic and hit Category 4 strength with winds 140 miles per hour in the Florida Keys, while weakening as it moved north but still carrying huge force. Air Force Command remembered Daisy and evacuated everyone from Tower 4 before Donna arrived, which turned out to be the right call. On the 12th of September 1960, Hurricane Donna hit the tower with winds up to 130 miles per hour and waves over 15 meters high. The storm destroyed the flybridge along with the maintenance platform below the deck that the divers used for access, and it badly damaged parts of the new above-water bracing. When divers returned in November, they also found serious damage to the underwater bracing, again concentrated in the AB plane in the upper tiers. The 1959 repairs hadn't held, and the 1960 bracing was already compromised. The tower had fallen into a cycle of damage, repair, and re-damage that sped up with every storm season. By late 1960, the main concern had shifted from radar and communications to whether it was safe for crews to man Tower 4. Unlike Towers 2 and 3, which stood in shallower water, Tower 4 had problems from the day it was built. Its shallow foundation, damaged bracing, and constant hits from deep water storms kept it in ongoing danger. The Air Force and Navy could fix parts of the structure, but they couldn't change the harsh environment it sat in. By late 1960, the men on Tower 4 knew it was no longer the stable installation it was meant to be. After Hurricane Donna, the platform was left bent and scarred, braces twisted, tiers cracked, and the flybridge torn away. The Air Force cut crew levels from more than 80 to just 28. Half Air Force personnel to run the radar, half civilian contractors to keep patching the structure together. The mission had shifted from early warning to sheer survival. Life on board grew harsher by the week. Storms rocked the tower so violently that welders could barely hold their torches steady. Men were thrown off balance without warning. Winter seas froze the decks, making even routine work dangerous. Captain Gordon Pillan saw the risk clearly. He requested evacuation several times, warning the tower was too unstable to withstand the winter. Each request was denied. Commanders on shore feared that leaving it empty would invite Soviet trawlers suspected of spying to move in. For those still on board, it meant one thing. They had to ride out the North Atlantic winter on Old Shaky. Here's the moment I recognize from so many other disasters. The men inside can see what's coming, but they don't control the decision. When warnings are ignored, the countdown keeps ticking until they unfortunately reach the point of no return. On Sunday, the 15th of January 1961, the weather closed in. By morning, winds topped 60 knots and waves climbed to 9 meters. The tower began to twist and sway in new, alarming ways. At 4 p.m., Captain Pellin called shore to report he believed another brace had failed. He warned that if the wind shifted, the whole structure could come down. Minutes later, a contractor spotted a half-meter crack in the base of one of the legs. They hoped to hold out until helicopters could arrive the next morning. But the storm only grew worse. By evening, waves were over 11 meters high and winds blew past 85 knots. Captain Pellin made a final call to his wife, saying the carrier USS Wasp was on the way. At 7:15 p.m., contractor Henry Schutz radioed his last words. "My next call will be from the Wasp or from the sea." Those words are chilling, not panicked, but certain. When a man speaks like that, it means he's already measured the odds and found them wanting. It's not fear, but resignation. The quiet acknowledgement that human will and engineering have reached their limits. His words are less a message and more a verdict, one that shows us how the men aboard understood the inevitability of what was coming, long before the ocean made it clear. 5 minutes later, the radar blip of Tower 4 vanished from the screen of the cutter New Bedford. When the crew looked out toward the horizon, the tower was gone, swallowed by the Atlantic. When Tower 4 vanished from radar, the response was immediate, but the same brutal conditions that brought the platform down made rescue almost impossible. The cutter New Bedford, already on station, radioed that Texas 4 had capsized. Other Navy units rushed to the area, and within hours, 5 ships were on scene. The aircraft carrier USS Wasp and the destroyers F.T. Berry, Norris, Lloyd-Thomas, and McCaffrey. The weather made their efforts nearly futile. With winds still over 80 knots, seas still rising, and poor visibility. Helicopter operations from USS Wasp had to be postponed. When conditions eased a little, the ships searched the spot where the tower had stood. Almost nothing was left on the surface. Crews found a smashed small motorboat, a floating mattress, and scattered debris. There was a heavy slick of diesel oil and gasoline, but no part of the platform itself was visible above the waves. At first, people wondered if anyone had survived inside the sunken structure. Submariners and divers knew of times where air pockets kept people alive for hours inside a wreck. The destroyer McCaffrey picked up a faint metallic tapping on sonar, hinting that something or someone might still be alive. Navy divers from shallow water teams went in despite the risk, working around a collapsed 7,000-ton steel structure. The reality is that the weather mainly affects the surface, and the deeper a diver descends, the less they feel the storm. They found the wreck mostly intact, lying parallel to the surface with jagged edges just 6 meters below the waterline. The surface conditions at that depth were too dangerous. Large twisted beams, unstable debris, and the chance of collapse made any search impossible. Civilian divers were later brought aboard Wasp to help, but they also couldn't find a safe way to search the interior. In the end, there weren't any survivors. The next day, on the 16th of January, helicopters spotted a body floating near the wreck. It was recovered by McCaffrey and identified as an Air Force Master Sergeant. Another body was seen, but lost before it could be recovered. Despite wide searches, no other remains were found. The men of Texas Tower 4 had almost certainly been thrown into the sea without warning when the structure gave way. In the freezing conditions and 85-knot winds, survival in the open ocean wouldn't have been possible for more than a few minutes. Divers kept surveying the wreck and found all 3 footings still embedded in the seabed. They saw the A and C legs fractured just above their base. They also saw that the B leg bent near its base without breaking. This showed the legs failed at their weakest points, matching years of cumulative damage and the overwhelming force of the January storm. All 28 men on board Tower 4 were officially declared lost at sea. Within weeks, investigators started asking if Texas Tower 4 was properly designed, built, and maintained. On the 3rd of May 1961, the Senate Preparedness Investigating Subcommittee held public hearings in Washington and called Navy engineers, Air Force officers, contractors, divers, and designers. Witnesses showed that Tower 4 wasn't like Tower 2 and 3 because its legs were embedded only about 5.5 meters instead of the 18 meters for the other towers, which left it less stable. Records showed construction damage, including dents about 25 centimeters in the A-B legs and broken braces before the tower was even finished. Underwater braces often used pin connections with oversized tolerances that loosened after storms, and one contractor opposed pin connections entirely. After storms, repairs kept focusing on the A-B shore-facing side, which had been damaged from the start. People disagreed about the 1960 above-water X-bracing, with some saying it increased wave-driven stresses and leverage on the footings, while others said it restored needed rigidity. Investigators found the collapse happened because the lower brackets and bracing kept cracking, and the very rough seas made it worse. Navy Captain Albers agreed, saying the waves bent beyond what the structure was built to handle, and the original standards should have been tougher. The inquiry looked at why crews stayed on the tower even after repeated calls to evacuate. Captain Gordon Pellin had the authority to order an emergency evacuation, but once storms hit, getting people off wasn't possible. His requests to remove crews before the storms were turned down. Air Force leaders worried an empty tower would attract nearby Soviet trawlers and kept the radar mission going even though intercontinental ballistic missiles were already reducing its value. It appears that safety was weighed against strategy, and strategy won, which is a pattern I've seen throughout the stories in this channel. Decisions made in meeting rooms for reasons of cost, pride, or strategy can survive in paperwork for decades, but at sea, they collapse in a moment. This time, the price was the tower itself and the lives it sheltered. 2 months after the collapse, prosecutors charged Colonel Banks, the acting Air Defense Sector Commander, Major Shepard, the commander of the 4,604th Air Support Squadron, and Major Stark, the executive officer, with culpable negligence, involuntary manslaughter, and Article 92, dereliction of duty. Prosecutors said the officers ignored warnings and didn't evacuate the crew, while the defense argued no engineering report declared the tower unsafe and that the storm time evacuations weren't practical. After several months, all 3 officers were acquitted. After the collapse, focus shifted to the still occupied Towers 2 and 3. The Navy rushed inspections using the original design firms, despite debate, and the surveys didn't find any immediate structural failures. The Air Force added new emergency escape capsules that could hold 7 men with 15 days of supplies, but they were never tested in real conditions. Even with that, people's confidence in the program was gone. By 1962, patrol aircraft with long-range radar made fixed towers feel outdated. And the Cuban Missile Crisis in October 1962 showed that long-range missiles were the main threat, not bombers. In 1963, the US Air Force ordered the Texas towers shut down. Tower 2 was decommissioned in January 1963, its legs were blown, and the platform sank instead of floating as planned. Tower 3 was decommissioned in March 1963 with extra precautions, and in 1964 crews cut away its legs and floated the platform ashore for dismantling. By August 1964, the Texas Tower program was officially over.